No, that's an analogy. Do you understand what a metaphor is? Okay.
I was just fair.
Although, to be honest, if I saw Miss Stewart, I wouldn't have run. She scares me sometimes.
So Miss Stewart is.
Oh, she's totally in charge of the lab. If I take Miss Stewart off, then like she doesn't make my labs.
Is that the lady with the lab coat?
Yeah.
Oh.
Yeah. Why are you so late?
We have a funny history. More giggle.
Oh, that seems reasonable. You came to class 6. Only reasonable excuse.
Can we tell them that you were running in the lab?
No. Well, yeah, you can. But if I find out who did that,
It's me. I'm gonna do that.
Wait, does he?
oh,
did he
it's
never
too bad you
confront
won't get into your university of first choice. With your very much required chemistry. Okay, I'm going to stop the vague threatening motions.
Vague. That was so vague.
Beer felt it necessary to text me that he did not use the upstairs bathroom. Oh! Eshwan, did you get the text from me about the upstairs bathroom?
Yeah.
Did you get the picture?
Yeah.
Okay. Like
I'd
half
rather you didn't send the picture, but I mean, sure.
let other people know, because apparently like half the people didn't get the picture.
No, that's
Yeah, that
I
was
don't have
so
an Apple
terrifying.
Yeah.
Pictures.
What happened?
Okay, let's move on.
Someone clogged the toilet with a bunch of paper and then peed all over it.
And is that a picture of it?
Yeah.
Who did that?
Well, actually, Mr. Newfeld. A few
Dylan,
days ago.
graph the change in concentration of volumes increase. What will happen
Concentration decrease.
to the concentration if the volume is increased? Dylan? Decreases. Volume is increased. Volume is inversely proportional, is proportional with the inverse of pressure and concentration. So when volume increases, therefore concentration decreases. That's a lot of symbols. What do square brackets mean? Concentration. So I'm using a shorthand. Dylan, I'm now sweating so much. It's all your fault. If we were making it less concentrated, which way would it shift? Now, first of all, is it balanced? No. So we got to balance it first.
I can't read any of that writing, Mr.
Well, then
It looks like
It says
invest in a pair of glasses.
if the volume
And for up here,
is inversely
balance it.
proportional to 1 over concentration.
Were those like $3?
Yeah, we're gonna go. No. Balance it. No, balance it first. I'm gonna answer your question.
2H.
No. Have you Oh, he's bouncing.
What's the line with the arrow below it?
It means decreasing concentration.
Volume.
Oh.
Also, this isn't
And
messy.
volume.
Volume.
3H2 and 2NH3.
3H2 and 2NH3. Just like this isn't messy.
No, it is. You can't read
Volume?
that.
What does that mean?
That's
It's
inversely.
inversely
Proportional to?
proportional to.
1 over pressure
I understand that part.
Okay.
But what's on that blabber after that?
and
Oh,
1 over concentration.
that is terrible.
What
Hand.
is that?
1 over
That's an and sign.
concentrate. You're talking awfully big for someone who's getting their quiz marked in 2 seconds. I
I
mean,
thought it was like
I
a-
say I do it anonymously, but do I?
I thought that was like the equal sign with the line in it.
That means does not equal.
Yeah.
Why'd you put
Okay, I don't know what you're talking
What's
about.
that?
Okay,
What's the empty brackets for?
what do brackets mean?
There's something in there.
No. What do they mean in chemistry? Right, so it's 1 over concentration. Increase in volume, therefore, concentration decreases.
Can you repeat what those $3?
I'll also try to have less coffee.
What's the line over the arrow for?
I just emphasizing volume.
Wait, volume over concentration decrease.
Oh, no!
You just highlighted it.
Oh, no, but those three, what are those $3 mean? You just read that.
Therefore, it means
It means
therefore.
therefore.
Wait,
Wait. Some people, everybody gets to learn something new every day. If you take the average birth rate and the average rate in which you learn information, there are approximately 10,000 people every single day learning that new fact, no matter where they are in their lives. So you get to celebrate with them. There's a whole bunch of symbols and logic. What does...
You're on it.
I'm on the other side. What does that mean?
Sin, because.
That means because. So if you didn't know that, you learn a new word so you can write faster. When you take logic, you'll learn there's all sorts of symbols to mean different words because they have mathematical reasons and logical reasons. Because is a premise indicator and therefore is a conclusion indicator, so you can rip apart the English language and start translating it into symbols so that you can treat it like math. Because as everybody knows, math is better. Pardon? Oh, I don't remember all. There's like this and this and this and there's like that and I don't know them all. Okay. Which way is it going to shift to increase the concentration that just went down? Which side can it go to make more? Left. To the left, to the left. Okay. So it's going to shift left. So it shifts towards reactants. But we also have a whole bunch of proportions to worry about because it's N2 plus 3, H2 goes to 2, NH3. So if it's shifting to the left, what will happen now, first of all, right away, as soon as the change happens, what happens to all the concentrations? They go down, they all decrease.
Instant, right?
Instant. And all by the same amount, because it's the same volume for all of them. But now, what will happen to the amount of N2?
It'll increase by N. Or like 1.
It'll increase by 1, because it's 1, 3, 2. Because now this reaction will use up 2 to make 3 of these and 1 of those. So whatever you draw, this is going to go up by 1. And I'm just realizing I've gotten myself to a bit of a hole because I made those so small. This is going to be hard to draw carefully. Maybe if I use a thinner pen. Yeah. And H2 will go up by 3.
Oh.
And not quite back where the original was. And NH3 will down by 2. And if I'm to draw little tiny, let's dash it. Little tiny dash lines just to where the and I already did it wrong because this doesn't go down by 3. From where does it go down? Do we measure that amount?
From the drop.
From the drop point. So we have to put that actually there. So this amount it drops by 2x. This goes up by 3x. And this goes up. Come on. You won't get hurt. That's good. And this go up by 1x.
Whichever side has more molecules, that's the side that it.
That's the side it goes to. So
But wouldn't H go down?
whatever you do, nature tries to undo. We decrease the number of molecules. Shifts
Thought we just increased
to
the space.
increase concentration / molecules.
But wouldn't that mean that H2 and N2 would go down if they're because they have more molecules, right?
Yeah.
So it would shift to NH3. They have more.
But they all got less, right?
Yeah.
So it'll shift to the side with more.
Is it just there?
That side has, and it's just about numbers. This has 4,
Yeah. That has two.
and that has 2. And that's it. Yes.
Wait, so for the graphing, we know that concentration's decreasing, but how do we know like if it's 3x, 2x, or 1x?
That follows.
Does it follow the coefficients?
Yes, it does. 2x, 3x. Ratio.
How do we know if it like drops and goes up? Or
then of coefficients. And then up or down depends on the shift.
Yeah, because if volume increases, concentration decreases.
Yeah,
So we know that for every single one it has to decrease.
yeah. No, yeah, at the beginning, yeah.
But then how do we know that? Oh wait, but why is NH3 going straight down and then H2 and N2 go down and up?
So which way did it shift?
It shifted towards the reactants.
Right. So which two will go up?
The reactants.
Reactants, and what will go down?
The
Is product. No, it's new. We haven't. This is the first time you've ever done shifting reactants, and it's probably the most important chemical concept. And we don't even introduce it to grade 11 because you have to learn how to name things first and do math.
So,
Question? NA?
No, not really.
Yes?
so it just shifts to one side and there's like more molecules on that side.
Yeah, it just shifts. There's more molecules there. Yeah. And you wanted to get into like why does the rate of reaction do that?
And it shifts based on enthalpy.
Yeah.
Enthalpy and max.
Wait,
Yeah.
can you go back down so I can finish
Yeah.
it? Okay, good.
Good then. Hold it. Nick, you said something about enthalpy. Why are you talking about enthalpy?
Like which side it shifts to, is that based on?
No, just number of molecules. Just the number of molecules. Because concentration favors the side with the most molecules. So if you concentrate things, the side with the most molecules gets the most concentrated, and that reaction rate increases the most. But if you decrease the concentration, the side with the most molecules is affected the most and has the most reduction in its rate. And so then it shifts to theirs. It's the weakest
So
side.
why does it want to have a higher concentration? Wouldn't that like make it require more energy?
The reason I'm looking up pensively is because there is no Y to it. It's just, and if you want a Y, like a mnemonic Y, it's because, whatever we do, nature tries to undo. We lowered the concentration, so it shifts to the side that will increase the overall concentration. By shifting to the left, we get four molecules for every two. If you want to know the actual reason, not sort of the why, but the reason, is that when you have lots of molecules, concentration just affects that side more. There's more molecules there. When you concentrate things, they react, their rate is affected the most. So when you concentrate things, this side will go faster, and so the forward rate will go to that side. If you decrease the concentration, they're affected the most, and so this side ends up being faster, and it will shift this way.
Oh, because there's less concentrated.
Less-
they
less
will react
yeah.
less quickly.
Yes.
So whatever side has more molecules, that's the side with, or that the concentration.
That's the side that the concentration increases, right?
That is if you decrease the concentration.
Yeah.
Now, if it made the volume smaller, which way would it shift?
The
other way.
concentration
The other way.
increases, so it'll shift to the product
So
side.
it'll shift to the product
So
side.
then the NH3 would technically be going down and up.
Yeah.
And the other two would just be going down.
Yeah.
Okay.
So, I did that, didn't I? Did I have an app that'll do that?
Flash still work.
I have to find the old Flash animation thing so that I can do that. And we already did this thing, right? Did we do this thing?
No.
Oh, so this is the explanation for that. So,
What is happening?
so don't write anything on this page. Just watch. This, I'm just going to put a bunch of this in. This is a simple reaction. It has 3 stars on one side. And remember, does the concentration at equilibrium mean that the concentration has to be even or in a 3-to-1, 3-to-2 ratio? No, they can be anything. Whatever the concentration, because we don't know this particular enthalpy and anything else, so whatever it is, this is what we ended up with. What is the concentration of this box if this box is 1 liter? Yeah, so how many particles are there? I wasn't counting.
1, 2, 3, 4, 5, 6, 25?
25?
Wait,
I got
okay.
24.
Okay, maybe 24 then.
It's 24, yeah.
Dylan's ready to be overruled. 24 per liter. We don't know what. There's stars and happy faces, but 24 particles. Now if I take this, and I'm going to make it smaller. Now, it is 0.75 liters.
It'd be 24.
What is the new concentration?
No bigger.
Yeah, bigger. By how much? Like literally. Do a calculation. What is that? What's 24 divided by 0.75? 24 times 3 divided by 4.
32.
32. We have a confident answer.
It's 30.
Is it 30?
It's 32.
30.
It's 32.
It's
No,
32.
It's 32.
You just learned an important lesson. Never second guess yourself. I was wrong once in my life. I was. I know. It's unbelievable.
Why?
But what happened?
How were you wrong?
That's the thing. Ms. Walensky told me I was wrong, and then when I went and I believed her because it's Ms. Walensky. And then when I went and double checked, it turned out I was right all along. So my mistake was believing that I was wrong.
But you
How
can
did
be
I
wrong
do
for
it?
possible before.
Oh, I've never been wrong. All of those are teaching exercises I do on purpose. Okay, we got 32. So the concentration increased from 24 to 32. And this is just an exercise to show you which way would this then shift to decrease the number of particles. Well, it'll shift to the right or to the left? Towards the products, towards the reactants.
Yeah.
So it will take 2, and it's going to try and make more. We went from 24 to 32. Whatever we do, nature tries to undo. Which way does it want to make it go? Less or more?
Less.
Less. So we want to make less. Which way do we go?
Smiley face.
Smiley face. So we're going to shift it that way. So the reaction then, there's way,
Wait, why is it going to smiley face?
we increased the concentration to 32.
Wait.
Felix? We increased the concentration to 32. We want to go back towards 24. We won't get all the way there, but we'll at least go back towards there. Which way would we shift to get less particles?
Smiley face, but
How many particles on this side?
3,
React to make,
2,
which is less.
2.
So we literally take 3 reacts, so you get a trio here, right?
Oh, I see.
It goes, hey, we're reacting. And then they go away, and then 2 come in. We've been transformed. And then you get another 3. Come on. No. One just tried to be, that's not something that happens. Hey. Ah. There we go.
Okay.
They all come out.
They all come.
We reacted. Then you get 2 more.
Oh, so because it doesn't want there to be that many smiley faces, so it's gonna.
Well, it's getting more smiley faces. Take out another 3.
Yeah, but there's overall less because it's decreasing by 1.
And then we add 2
Oh, yeah.
smiley faces. Yeah. This board doesn't have the best pens, but also, again, less coffee. No. Now we decrease it. We probably didn't decrease it all the way, but how many particles are in here now?
6.
20.
Oh, sorry.
In total.
Overall.
Uh,
Overall.
1. I don't know.
21.
Because you took out.
It's 21, yeah.
21. And if I took out 21 and I divide it by 0.75, what do I get?
20.
28.
28. And maybe that's the end of the equilibrium. Maybe it keeps going. You'd need to know the equilibrium constant in order to figure that out. So it's not going to go back to the original 24, but it is going to go towards it until their rates equal out again.
Isn't there an equation for this? And then
The
it's-
KQ equation is coming up. Yeah,
Yeah.
that's the very next unit.
Isn't that the ice table?
And then we do ice tables.
Yeah.
Ice tables. Old Flash animation. I really want to play that. Okay. Graph the concentration of the volume. So we just did this, but now we're decreasing the volume. Go and do it. I'm going to go see if I can play that flash animation.
But it's only
I have it. I just nothing plays it. You know, because they carry viruses. I don't know. That's IT's problem. Maybe I have Shockwave saved somewhere from like the early 2000s. Look what I found. I actually have it. It's from 2003. Download. Scanning for viruses. It was an Adobe project. There used to be a ton of games on it. It was really easy to program. And then it turns out because it was easy to program and it could do things with your disk, people could very easily make. Hold it, where'd it go?
malware.
Yeah. Wait, where's my download? Go away. This this file type might be dangerous. Download anyway.
Don't you get like an angry email from IT?
They don't know half of what I do.
I think
Staff are allowed to have VPNs. I mean, I would never do anything that was incorrect on the Brentwood network for anybody who might be listening.
What do you need a VPN for even?
There's tons of sites you can't go to that are educational sites. There's a website, I used to teach biology 12, that will show like actual operations, like medical download. You can download videos of like a heart transplant. And they're blocked because it's graphic content.
Mr. Miller just looked some on YouTube.
Yeah. Pardon?
Mr. Miller just wanted some on YouTube.
Maybe they're more open now. Okay, where's, again,
What's taking so long, Mr.
I don't know. I want it.
Mr. Neufeld, what would happen if I would like submit a virus on Google Classroom as my homework?
would you give us extra credit for that?
No. You would be in violation of the acceptable use process, because this has happened once before, acceptable use policy of the school, and it's actually a suspendable offense.
Oh, if you didn't know.
Yeah, the case I'm thinking of, there's been a lot of cases where people that, didn't know, but you're normally submitting documents. It is possible for an old Word document to have a virus on it, but why are you uploading something made in like Word 1995?
When you put a thing on your computer that would like, I could just like change the grade like in the middle of the night when you're sleeping.
That would, if you can do that, would take some effective programming, because the grades aren't really on, they're on Mr. Wardrop. You'd have to be able to navigate the internet from a different computer. If you could do that, you could just do it yourself on your own computer.
Well,
I need your
not
login.
necessarily though, because he'd need your login. I mean, once you get the login.
Yeah, but you don't need my computer to get my login.
Well, how do I get your login?
I don't know.
If someone was like
Social
to
engineering.
get your
Yeah.
device,
Yeah, you just,
could they
if you
change
want to get the login, just ask a teacher for their
Also,
login.
like, if you're smart enough to figure that out,
Yeah.
you're probably smart enough to have good grades.
Yeah, for real. So would you give us a good grade?
Yeah.
No.
Maybe you're just too lazy.
Hey, wasn't one year, didn't that one guy, like, make it to that all of the oral assignments didn't work, but then they were, like, found who he was and was like, we're kind of mad, but also can you show us how you did that, and can you try again to see if we fixed it?
That kind of thing happens too. Okay, I can't get the shockwave working. Maybe I can get it next time. No, I'm not helping. You're going to go up there. You have to answer questions. Ask the people around you.
Oh, I mixed this up.
How do I know which way it's
I wish I could have
I
this.
mixed the one and
How am I gonna know what it should be?
Oh, did it say no?
No, it's just not.
Increases. So what does that
I
mean?
think it's gonna be really messy. We're gonna get a virus, it's gonna be a whole thing.
It should be applied now. If the volume is decreased, then the reaction rate is going to increase.
But I don't understand.
Ooh.
Mr. Neufeld,
Shh. Very important things are going on.
happens if you increase concentration, the rate of reaction increases.
Forward.
The forward rate of reaction increases. Therefore, the products are being
If you make the concentration higher, nature will make concentration lower again. To make concentration lower, you need to have less particles. So it goes inside of less particles.
I thought it should include this one and
What is the
So what was your
of?
explanation?
If you make concentration higher, nature wants to make it lower. If nature wants to make it lower, it just has to go to the side with lower concentration, which is the product that it uses.
It said it installed it. I think it lied. Yeah, it lied.
Because it has lower entropy.
Oh well.
Because it has
I will see if I can fool around with this later. I thought if I could get it to work quickly, but no such luck. There we go. Okay, NO plus CO2 goes to NO2. Graphic change in concentration of the volume is decreased. If the volume is decreased, which way is it going to shift?
products.
Products. Why?
Because if the volume is decreased, the concentration increases.
Yeah.
So the reaction rate and then going forward is decreased.
We want to reduce the concentration because we increased the concentration of everything. Everything went up, so we want to decrease the concentration. So it's going to shift to the products, which is NOCl. Now, first of all, what happens to all of their concentrations?
goes up.
They all spike. And what happens to the product concentration?
It goes like
Goes like that. I like how you just sort of drew it in the air. We will do that in that color. And by how much will it go up in terms of ratios?
2x.
2x. So whatever I do here has to be double what I do for which one?
Double CL.
Double CL. So does CL go up or down?
Down.
Down. So this should be just 1. What happens to the NO?
It does the same thing as
Down.
NaCl. Wait.
Goes down by
Oh.
2. So that would be about,
Oh.
that's pure coincidence, by the way. They don't have to meet. It looks like they're kissing.
It goes
again.
down by 2 or goes up by 2? Correct.
NO?
Yeah.
What does NO do?
2x goes up by 2x.
Which way is it shifting?
Up.
Not up. No, which way is the reaction shifting? Up to,
Oh,
the,
to the products.
to the product. So what will happen to this amount?
It'll go down.
It'll go down.
Like overall it goes up.
Overall, it goes up, but
Oh.
then it goes down. This,
We wanted to reduce.
and this is then one of those tricky things. What happens to the concentration of all species? That was a stupid drawing.
So from the part where it peaks.
I went below the black line. I can't do that. In fact, let's use a different color.
What's that one?
That's a stupid thing. Where'd my? Oh, there. Oh, well, the reaction shift towards. So we answered all that. Reaction shifts towards the products. If pressure is increased, i.e., volume is decreased, the reaction will shift to the side with the least. Is a good word.
What?
If the pressure is increased and there's more concentration, it shifts to the side with the least number of molecules. Whatever you do, nature tries to undo,
Up.
and it wants to decrease the concentration. Oh, we're almost ready to finish. Are people ready for this one? Anybody not ready for this one? And this one I just want you to guess. We have this reaction. Okay? Okay. We have this reaction, and I add a catalyst. What does the catalyst do to the rate? Increases it. So how will that reaction shift?
It's gonna want to decrease it.
It's gonna
Thank you
shift
so much.
to the.
It'll what?
Nature's gonna want it to decrease it
Decrease. Sure.
by
Yeah.
shifting it towards the product.
Towards the products. But what did a catalyst do to the rate?
It increased it so.
Right.
It lowers activation energy.
It lowered the activation energy. So you had this. Now you have that. What will that do to the forward rate? Increase it. What will that do to the reverse rate? Increase it. Yes? And then yes.
Isn't this reaction exotherm?
Oh, right, yeah, it is. Because of that. So was this, now it's that. So both rates increased. So which way will it shift? Neither. Catalyst is absolutely nothing for equilibrium. It just makes equilibrium be. This would be like, remember when I had you walk around the table and I said, this is dynamic equilibrium.
Yeah.
And then I took you outside and I force fed you some meth and caffeine and cocaine. And then I brought you back in and I said, you know what we're going to do? And you're like, what? I said, run around the table. You're like, ah! You just ran around. The equilibrium, the number of people on both sides wouldn't change. You'd just be doing everything a lot faster. So, if we put T1 here, then we go here, and there, and there, and then we have T1, the concentrations, there's no shifting, it's exactly the same. This is a trick question that they give you. If we were to do time and rate, whereas red is the forward rate, blue is the reverse rate, and blue and red, as I've learned, is purple. And we're going to have T1. It goes to here. What happens to the rate when I add a catalyst?
Increase.
Increases. Both of them increase. And then what do they do? No?
And
They just keep going. You fundamentally changed the system. You lowered the activation energy. It's a brand new reaction. I mean, the product's the same, reaction's the same, it has a whole new mechanism. So nature doesn't try to undo that, it just keeps going. So this is not this is not considered a change to the equilibrium. Equilibrium remains the same. Both rates have increased by the same amount. Same if you add a poison. Poisons just decrease both rates.
Mr. Neufeld,
Yep.
what are the colors on there? I can't see them.
Forward rate is red.
No, on the graph itself.
Oh, green and then purple?
Green and purple.
Yeah.
Are you colorblind?
Why green?
Because I liked it and Ellis gets too much hate sometimes.
No.
Even by me?
No.
Wait, I genuinely.
You're in Mackenzie.
Yeah.
No, on the.
I do say it does warm the cockles of my heart for the Mackenzie hate of Ellis. Yes? Sophie, go.
On the second one,
Yeah?
what is the colors of the line?
This one?
Yes,
It
I
just-
literally cannot see.
It just says T1.
No.
It's all
one
purple. It's
color.
all purple.
It's all purple.
This is all purple.
Okay, thank you. That's
Yeah,
good.
it's all purple because what does red and blue make?
Purple was
And the
actually
forward and reverse
color.
rates are always the same.
Yeah.
So they're either the same, they increase the same, and they go forward the same. It's all the same.
They're constant or not equal or constant.
They're equal even if they're not constant. Because we added a catalyst, so it jumped, but they both jumped the same amount. That was a good question. Now we can fill in the words.
So I don't understand like which side shape, right? Is that,
Who said this in the film? Okay, what does a catalyst do to the activation energy? Lowers it. The forward and reverse reactionate both increase
By an equal.
by an equal amount. I don't know why there's two words there. Maybe I used to say go up. A system at equilibrium
Stays.
stays at equilibrium. Excellent word. If a catalyst is at. Yes?
So, if the reaction rate increases, it doesn't cause a shift to the right or to the products?
It does, but what did the reverse rate do? Also increases. So the shift is identical. So they're just both working twice as fast.
So it's only catalysts?
It's only catalysts. Yeah.
Other forms of increasing the reaction rate of one
So
side?
yeah, and the classic one is temperature, because the temperature is affecting the proportion of molecules that can actually go over the hump, whereas catalyst is providing a new path for everybody equally.
So an increase in temperature would cause there to shift to the reactant side?
In this particular reaction,
Yeah.
an increase in temperature would shift it to the reactant side because it would decrease the heat. Yeah. And a lowering of temperature would increase it to the product.
It's basically the less energy. Never mind.
Good.
Wait, what about that one? If not an equilibrium.
So if there's more energy on the reactant side, then it would decrease the rate, right?
Are you talking about now temperature or catalyst?
Temperature.
Okay, so if we did this reaction and you increase the temperature, which way would it shift?
To the products?
If you increase the temperature, what are you increasing of all these things on here?
You're increasing the rate.
The heat. You're
Oh.
increasing the amount of heat. And you're actually, way back when we ran, remember that curve that you probably did in your head and that would go like this and it tails out?
wait.
You're increasing the proportion of molecules that have enough energy.
Wait, so
Um,
because you're
And it affects this side most because they're the ones that have the heat term. So you increase this, it would shift which way? To the reactant.
Oh wait, what?
Because it's like, it's.
Oh, it's asking what the equilibrium is going to shift to because it tries to undo what that
Yeah,
did.
yeah.
Oh, so whatever it's
Yeah.
actually shifting to is shifting the opposite.
And when you look at the proportion of molecules that have enough energy, they are affected if they're down here. They're affected the most. They need the most energy. So if you increase the heat, they get a bigger benefit out of that.
Oh.
Another way of saying that is if you looked at your graphs where we looked at, if you remember your Hebden, and it did this, and it had different heat curves at different temperatures, and it sort of pulled out. The proportion that are affected that can meet that energy, the tail is bigger for that proportion for those molecules, even at the same temperature, if they have a higher count. You get more benefit out of it. To explain it more, I'd need to actually graph it out and do math. At this point, that probably wouldn't be a useful expenditure, but could do that. Do that in the future. But in terms of catalyst, nothing will happen. It affects both sides equally. Because it's not giving both sides energy. It is just giving it a brand new path, and both of them are equally advantaged by that.
Just one more sentence there.
Pardon?
One more sentence. If not,
Is there? Oh, if not at equilibrium, it would reach equilibrium more quickly. I was going to write quackly.
Is it possible to decrease the rate like you increase the power?
Yep. You could add a poison, and then the rate would drop and then go straight. A poison is just a reverse catalyst.
So something like, yeah, it is.
Well, if you're doing it on purpose, we usually call them inhibitors.
Yeah,
So they're biological, they're poisons. And biological poisons often stop it entirely. It's now in equilibrium because it's a static equilibrium. Everything has died. But an inhibitor will just slow. It gives it interferes with the molecules, so their new reaction path just takes longer to do, and it usually has worse geometry. And that's important, especially for reactions that happen very quickly, like explosive reactions. If you have an explosive reaction, you might want it to happen more slowly so you can extract all the energy from it, rather than it, say, blowing up your equipment.
You don't want to blow up your equipment?
You don't want to blow up your equipment.
That's the most fun part.
It is fun. There's a lab in Germany. They seem to have the best time. They are the world experts in explosive materials. There is a crazy molecule. I mean, if you look it up, it basically just looks like this. Like it just has tons of nitrogens and oxygens on it. It is the most explosive compound in the world. It's so explosive we don't know how explosive it is, because every time they manage to get it into the machine to measure that, it almost always blows up on the way there, and they can't find an amount small enough that doesn't damage the machine to the point that they can get a reading out of it. So they can't even get a reading when they
So
have
is it
managed to get
worse
it.
than you?
Pardon?
Is it worse than you?
It's not that it's like it doesn't blow up the whole lab. They're using tiny amounts of material. It's just that it's so sensitive. Like everything sets it off. It's incredibly unstable. And there's a lot of energy in a very small amount. So,
but
yeah.
like if you had it
A
in
nuke is way more explosive. Pardon?
So if you had it in a larger amount, it wouldn't matter. It would be
No,
less
and you don't get radiation out of it, so the nuke is dangerous in all sorts of other ways.
Is there anything worse than
How is a nuke made?
Well, in many ways, maybe, I mean, a nuke is bad because it kills many.
than a hydrogen.
But if I was being attacked by a bear right now, I think the bear would be worse.
That's true.
Bears will eat you alive.
Yeah.
Sorry, you probably didn't need to know
Evaporate
that. I'm
you,
sorry.
basically.
But black bears are so nice. Grizzly bears are the mean ones.
Grizzly bears have made it to Vancouver Island as of 10 years ago. They're in the North Island and they're making their way south as they slowly explore the new habitat.
Really?
Yeah.
How did they get here?
The same way our deer got here and everything. At some point, there was a storm and they managed to float over and didn't drown. That's how all of them. Nobody caught it and released it. It wasn't in a zoo. It just, that's how animals get on islands. Eventually, one just makes it over.
What if it got
Our deer are small because they came from mainland deer, and then over time they adapted to the environment. We're a smaller island, so you do better if you're smaller on islands. It's a evolutionary trend we always see on islands, and so they became a little smaller. I did meet people from the interior, and they're like, "Why are there so many baby deer?" And I'm like, "No, those are our adult deer." But yeah, they're here. The grizzlies are moving south. Yes.
What if it just gets into
Oh, did I not? Quickly.
How does it accidentally go here?
Yeah, for real. You see it and it's there.
Wanders onto a ferry.
Yeah, he's like, what if they just came across? How would that accidentally happen?
Yeah.
Like a rat or something I can see accidentally.
Okay, last one before we have a little brain break because I'm going to give you a history lesson. Huh?
Wait, can I-
Yes, question? Bears?
Polar bears and grizzly bears make me really scared.
Oh, yeah. Because polar bears are moving south because their habitat's being drowned.
Polar bears
in.
and
But
grizzly
then
bears
they're
breeding.
like
Yeah,
polar bear size, but grizzly bear
Imagine.
aggression, and it's
That would be
going
like
on.
yeah.
a ultra
They look really
alpha
pretty though.
bear.
It's not friendly.
Polar bears are hugely aggressive.
They're making really,
They
really
eat their own children.
they're making
What
really
do?
pretty bears,
Male polar bears.
and it's
Oh,
their
yeah.
friend, white friend.
Just casually.
Okay, Nick, hold it. What? Why do you have your laptop out?
Can we have a burglary?
No, put it away.
But it's
Those aren't
bears.
even bears. Those were like red pandas, which are I think are a type of fox.
Yeah.
They're like raccoons.
Okay,
It's a mix.
this is the last thing before I discuss some history. So there's not going to be any graphing after this one. But this is now to take all your knowledge of equilibrium, like we just did, the most important process in the entire world. I am now writing it in all caps, apparently, because it is that important. It's called the Haber process, sometimes the Haber-Bosch, I think, which you may have seen on some things chemically wise. The Haber process is the most important process in the world. If it wasn't going on right now, between 3 and 4 billion people would start starving to death. This feeds the planet. Because you need nitrogen for plants to grow. And plants, most of them, cannot take nitrogen out of the air. It's a really stable gas at the bottom of a very big enthalpy hill.
Comes from lightning.
Notice, this is an exothermic reaction to go, hold it, this is exothermic? Ooh. No, I did that right. No, I've written it the wrong way around.
What?
That's why I confused myself.
Oh.
Undo.
That's a product.
Yeah, no, I know.
It's
I'm
a
trying to
reactant.
group. Ungroup. And the part where I put it wrong is that this is what we would normally draw an exothermic reaction like. However, This reaction is more like this. It has to get over this huge, all the way up here, all the way down there, energy hump. And N2 is N, if you remember your Lewis dot diagrams for last year, triple bonded. It does not want to break. It's got that a huge amount of activation energy to do. So you have to snap that, react it with some hydrogen, you get some ammonia. Now there are some plants that actually grow some bacteria in their roots that can do this, and they can add nitrogen to the soil. And that's part of the nitrogen cycle. It's a slow process. It's difficult for the plants to do. Haber is a German chemist, managed to do this. He was immediately branded as a war criminal, as we'll go into when we do the history section. Because if you can make ammonia, you can then very easily make nitrates. And nitrates are explosives. So all the nitrates that we use in the lab, you could take them away and build a bomb like that out of them.
Oh.
So, and he was making this not to feed the world, but to make bombs for Germany. He was in World War I, he was a decorated soldier, he was also a chemist. He really wanted to help Germany out. They were limited by the nitrate supply. In the olden days, militaries didn't make this stuff. They didn't go to arms manufacturers and like, can you make us some nitrate explosives? The arms manufacturers would go find bat caves where bats had been like pooping for hundreds and hundreds of years. And they dig out all the crap because poop is full of nitrates. And they would just pull the nitrate out of there. And they would pull out the urea and the piss and everything else. And they'd refine that. The wars were fought over bat caves because that's how rare it was. And every time you blew up something, you're also using up potential food because you could also turn it into ammonia and put it on a field and double your growth. Fertilizer is what is currently feeding the world. And if you like, oh, I don't use fertilizer, it's going to be organic. Yeah, you pay a higher price for that, but if everybody did that, we would have to ask 4 billion people to starve to death. We could not feed our planet without fertilizer. They would all die. We don't have enough arable land, and our cities keep encroaching on our arable land because people go, hey, this is a nice place, I'm going to build a town. You build a town, you have a lot of farms, and then the farms go away, and you build a city, and now our best land is currently sitting underneath most of our big cities because that's where we built their cities. So we need to make the most use we can. We need to make this, and we need to make a lot of it. So we came around. How are we going to increase the rate and equilibrium of this so that we have the most we can have? How would you do that? Yeah.
I'm sorry, this is a separate question. So does that mean like the fertilizer itself can make bombs, or like it's like you can turn this into?
There are certain fertilizers that they themselves basically are a bomb. I may have wanted to experiment with that because I grew up on a farm and I knew a little bit of chemistry, and I was like, so I ordered some of that fertilizer. And then my dad got a call from CSIS. Why are you trying to order fertilizers that also are for explosives?
Wait, he actually did?
Yeah. Has anybody here heard of the CIA?
It's the Canadian.
Yeah. CSIS is the Canadian CIA. They're much better because we've never heard of them.
It's the most secret.
Yeah, and you need to have a special permit. And I'm like, my dad was like, what are you doing? And I'm like, I just wanted to blow something up. And he's like, go invent gunpowder like you did last week. And then I did that instead.
Did you just like increase the pressure?
Yeah, so one thing, increase the pressure. Perfect. So I'll just put it here, increase pressure. So if we have high pressure, which way is it going to shift?
Towards the product.
Toward the product. So you want a high pressure system, a really high pressure system. That'd be perfect. What can we do with temperature?
Increase?
If we increase the temperature, which way is it going to shift?
To the right.
To the right. If we, so what should we do? Make it cold. If we make it cold, it's going to increase to the products. At what rate? Very slow.
Oh,
So we got a problem with temperature.
Just don't touch it.
So just don't touch it. We want it both high and low. So So we're gonna just find the temperature that works. We want to shift it to the right, but at the same time you can't have a slow rate. So you just have to play with temperature and figure out what medium temperature works. Dylan, good question.
wait, so no matter if we increase or decrease the temperature, it still shifts the products?
Which way
Oh,
will
I see.
if we decrease the temperature, it'll shift the products. Do we have to worry about,
But if we increase it, it'll shift to reactants?
yeah,
What?
sorry, say that again?
If we increase the temperature, it shifts to the reactant.
Yeah, at a high rate, because we've increased the temperature. If we decrease the temperature, it'll shift to the, Dylan? If we decrease the temperature, it'll shift to the
Product.
products at a slow rate, because we've decreased the temperature.
But if you increase it, it's gonna shift to the reactants.
If we increase it, it'll shift to the reactants, but we have a higher rate. So we're gonna have to find something in between, where we can get it to the products, but at the fastest rate possible. Do we have to worry about surface area with this system?
Okay.
What surfaces when I surface area?
Yeah, surface area. Like, do we have to grind anything up?
No.
It's all gases, so we're gonna be fine. We got a type of system, closed or open? Closed. Because if we let any of this escape, we're not gonna get it. However, what area might we want to be open? What would drive it to the right? In terms of concentration, what would you want to take away?
The NH3.
If we manage, this is a gas, but you know ammonia as a liquid in cleaning compounds. We could pull this away in some way. We could constantly drive it to the right. And part of the advanced systems, they'll actually have that precipitate out like rain, and it will come down the bottom, and you'll just siphon it off, and that way it's continuously decreasing in concentration. If you decrease the concentration, the equilibrium shifts to the right. So you make it a little open.
But aren't you trying to get NH3?
Yeah. So if you get it out, you're getting your product.
Oh, I see.
And you're getting the equilibrium. So you just keep supplying with more N2 and more H2, and you keep going.
Infinite,
How's it liquid though?
infinite reactant.
Oh, just keep it at a pressure and a temperature that where it's close to that, and you can like adjust that.
And then it doesn't go back.
And then and well, also, what would you want these concentrations to be?
Very high.
Very high. This side very low, as much as you can. So that's the overall reaction. Let's see if I've got a. I think I have something in here. Like a box. Like a weird box. Oh, hold it. Is this a box? This is a box. Aha! Nobody said catalyst though. -1 point. Plus points for all the others. Find a catalyst, number one. If you can find a catalyst to make this go faster, that'll help with the temperature problem. Because at least then you can lower the temperature and still make it go fast. You want high pressure, low volume. So very, very thick walls, super high pressure. Continuously inject N2 and H2, so you have a high amount of your reactant, so they're always shifting to the right. Medium temp to balance the rate and equilibrium. And then just keep taking away the NH3 as much as you can. Just get that going, get that going. And then, once you're done writing that down, and I'll wait, I gotta talk about Haber, because this is such a story. And just to give you fair warning, it's not a nice story.
What about the test? Do you have
We have a quiz, 11:45
bathroom break?
is when class ends.
Do we
It's
write
a
that down
15-minute
on the
quiz.
box? Do we write
Wait.
that down on the
I'm
box?
still wait.
No.
Where do we
What?
write that down?
Confused about like the decrease the temperature it's just the products, increase temperature it's just the reactants.
Yes.
But why? Okay, why?
Because if you have more like reactants.
Oh, hold on, I'm gonna put it here. This is an exothermic reaction, right?
Yeah.
So, A goes to B plus heat.
Yeah.
So on a purely matter of whatever your nature tries to undo, if I'm gonna use that method, if I increase this, how does nature take away the heat?
By shifting it to reactant.
Reactant, so
I know
use
this now,
heat,
okay.
it'll make B plus heat will make A, and then the heat will go away, it'll go back down again.
Okay.
So it'll shift the reactant. If I decrease the heat, so I lower the temperature,
Yeah.
then by shifting to the products, you get B plus heat, and that helps raise the temperature.
Oh, so
So
that
that's
just helps
undo.
balance it out.
So it balances
Oh,
it.
okay. I get it. Yeah. Okay. Now I get it.
There'll probably be a couple more times. And this class is over at 45. Oh, I was hoping to have time for the story.
No, let's do the story.
No, we're not gonna do the story, we're gonna do the quiz. But there's a guy, there's his wife, people die, Canadian soldiers commit war crimes, it's amazing.
Is there a movie about it?
to hear it now.
Yep, next day.
Dude, doesn't his wife also kill herself? Is there a movie about it?
Stop spoiling.
And no, it's not, it's what, literally everybody commits suicide in this story. And some people commit murder.
No, he gets a hard time.
I wanna know the story, not the
I
plan.
believe it was suspected he took his own life, didn't he? Did he die of a heart attack? Oh, okay.
That's what they want you to do.
Yeah, once you
How they killed him though?
Pardon?
Actually assassination.
Assassination.
Okay. I will hand this out. Please put away everything off of your desks. You get a brand new data booklet with a new picture. Please spread out. It's prettier. Nobody sent me any artwork, so I drew my own.
I think
Yeah.
people need like more time ahead.
We never even use these, Mr.
If anybody gives me artwork at any time, I'm going to put it on the new data booklet.
Like this shirt.
So I asked AI. I want actual student artwork.
This is
My
AI.
art contains
No, I think it
this.
makes sense. No, but it's like, do you think it makes sense?
Okay, you have to separate out. Separate. Put all your stuff away. Separate. Yeah, binders away, notes away, separate.
If I said you
Fine. Probably necessary, but look. Martin's not here. I may not. Luca. Felix. Separate out, move tables, there's a whole clear over here. Nicholas. Taylor. Eric. N.A. Put your notes away. Ah, pass it in there. Echelon.
Yeah.
Pass that to Echelon, Mr. Slot. Luce is not here today. Sophia. Eddie. Dylan.
Yeah.
Me. Sabine. Inara. Nick passes to Inara. James.
Hi.
Oh my God, James, your head has been here for like almost a week.
Sorry, yeah.
Pick it up.
Oh, yeah, solid that they.
So reminder, make sure you put your version number there at the bottom once you get it, otherwise it will like mark it incorrectly. Oh, yeah, it is. Top of the quiz should say KBAT D. That's actually just me not changing it from the last quiz. Please cross out C and write D. Very top quiz topic. Or ignore it. I'll figure it out.